Earlier in this section, we ended up doing integrals of this form with sines and cosines raised to various powers. Let's think about what happens if we have tangents and secants, the products of tangents and secants raised to various powers. So here is one example that we might want to think about. And the key trick is we're going to want to use this version of our identity here. We can replace tangent squared x with secant squared x minus 1, or we can replace secant squared x with 1 plus tangent squared x. So we're going to want to make good use of this. Okay, so this is the integral that we want to deal with, and here's how we're going to deal with it. We're going to observe the following. We're going to split off a factor. So remember before we were splitting off a factor, either sine x or cosine x, because it was the derivative of the other one. Well, in this case, the derivative of tangent x is secant squared x, and the derivative of secant x is secant x tangent x. So what we're going to do is we're going to split off a factor of secant x times tangent x. Okay, so this is our first step. So note here, we still have 3 powers of tangent, tangent q to x, and we have secant x to the 5th power, and we recombine everything. And so this is going to be, we're going to say that this is going to be du. Du is going to equal secant x tangent x, and that happens exactly when u is equal to secant x. So our goal now is that we need to write everything else over here. We need to write that in terms of secant x. So we've got the secant to the 4th x, that's fine. And so we have to now use the fact that tangent squared x is equal to secant squared x minus 1. So we'll need to use that here. So we make that replacement, and what do we end up with? The integral of 1 minus tangent squared x, oops, sorry, that's supposed to be 1 minus secant squared x times secant to the 4th x, and then still we have the times secant x tangent x dx. And now we can go ahead and say, make a replacement. Now everything over here, there's no tangents left here, it's only secants. And so this will be the integral of 1 times u to the 4th is u to the 4th minus u squared times u to the 4th minus u to the 6th. And all of this becomes du. Okay, so what do we end up with? The integral, well, let me recopy, u to the 4th minus u to the 6th du. When we integrate this, we get u to the 5th over 5 minus u to the 7th over 7 plus c. And our final step needs to be to substitute in. So u is secant x. So there is our final answer. Okay, so in this problem, we split off a factor of secant x times tangent x. And then we were able to substitute in u is equal to secant x. It's also possible for us to make the other choice in certain problems. So in this problem, instead of substituting in u is equal to secant x, we're going to substitute in u is equal to tangent x. So let's just already say what's going to happen here. I'm going to say u is equal to tangent x, and du is going to equal secant squared x. Let's see what we have to do to make that happen. Okay, so we're going to split off a factor of secant squared x. So here comes the secant squared x dx. That's going to be our du coming up. And we want to get everything in terms of tangent. So we're once again going to replace, and this time we're going to go in the opposite direction as in the previous problem. Secant squared x is equal to tangent squared x plus 1. Okay, so now we're ready to make our replacements. This is du. This is u squared times u squared plus 1. And this ends up multiplying that out, gives us, we'll put it in the same order, u squared plus, u to the 4th plus u squared du. And when we carry out this integration, u to the 5th over 5 plus u cubed over 3 plus c. And just as before, our final step needs to be replace our u's with tangents. And that is our final answer. So very similar process to before. We want to split off either secant squared x, so we're going to substitute in as u is equal to tangent x, or split off a factor secant x tangent x if we want to substitute in u is equal to secant x.